So, so let's run the debugger here. So I'm right now stopped at this loop here. In the debugger, I can see the local variables. So I can see that what my I value is right now. Oh, actually not, because I'm not in yet. Let me step into it. Now I can see that I is 0. Notice that I had to scroll a little bit here because this display is kind of small. What I tend to do when I have lots of local variables, I make this window a little larger, and then I get to see more things here right away without scrolling. That happens all the time as your programs get more complex. So here, now I want to know what's inside numbers. Notice that it says here, numbers equals some object reference. Okay, how do I get into the thing? I double click on it, and then I get this nifty display here that says that I have an array of length 14, and I have these various numbers in here. So now I'm going to click on next again. What's that? I lost my window here. Or on step. But before clicking on step, there's an important thing I have to do. What do you do before you click on step? What do you do before you click on step? Very important. You ask yourself, what's going to happen? And I swear, this is the most important part. Because if you use this thing like a remote control, and just do click, 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 and step through the thing, it's not very useful. But if you ask yourself, what's going to happen, then, so let's try this. So I'm going to execute this line. Numbers I equals numbers I plus 1. I know what I is. I is 0. So what is number 0? Very good. It's 37. And I like that you said 37, because when I asked a bunch of other people what's number 0, they said, oh, it's this. But when you say 37, that's a concrete answer, right? It really is 37, right? Number 0 is 37. What is numbers 1? 61. So now when I click on step, what's going to happen? So should the 61 move into here, or should the 37 move into here? So he says the 61 moves into here. Let's try it. And he was right. Okay, the 61 moved into here. And now, what if I had been wrong? Someone else, when I walked this with a couple of students, they said it was the other way around. And when it's wrong like that, then you need to ask yourself, did I misunderstand, or is there an actual bug in the code? And you just have to then carefully look at the statement. And with me, it's usually 50-50. Half the time, I'm surprised because I didn't quite understand the situation. And then something terrible happens. Namely, I'm learning what's actually going on. But that's life. Or maybe I actually found a bug. And then I know that I need to fix the bug. But so either way, the debugger is not very useful if you don't carefully look at the numbers, if you don't have expectations. So before clicking step, have an expectation. So now, what's my next expectation? So I click on the next line here, numbers I plus 1 equals numbers I. And what do you think is going to happen? So my original expectation was, well, I was going to swap these numbers, right? So my original expectation was, well, then this thing should change into whatever it was before, 37. But now my original expectation is beginning to falter a little bit because I'm looking at the code and numbers of I, well, it no longer has the old value. So this is probably not going to be able to work, right? I wiped out the old value. So when I click on it, that indeed, now they're both the same. So this strategy that I had here, where I said, let me make it vertical because they're vertical. swap these two values, move this one into this one, and move this one into this one. That didn't work. Oh, actually, that's not what I did, right? I first moved them like this, and then I moved them like this. But it didn't work because this move here wiped out the old one. So what do I have to do?
Make a new variable.
So I'm going to show you what the cheaters did. They drew this picture. Here, just proof. That's what they drew. Right? So if you first move one of them into some temporary location, then you can move in here, and it doesn't matter that you're wiping out the old one because you have it in the temporary, and then you can move it back. So that's the trick to deal with this. And that's what you have to do. So the code for it is not difficult. So over here, instead of moving into numbers I should move it into some temporary. Then over here I can do the move the normal way, and now I say numbers I equals temp. And that's exactly the three-way move that we've seen on the picture before. So here's my temporary. So I move this one into the temporary, that's here. I move this one into here, and then I move the temporary into numbers.
Would you dock us down for more work if we stored two integers?
Oh, no, that's fine. So another way of doing it, that's actually a great suggestion. Just, what you have to is, you simply copy both of them.
Yeah.
Yes, and nothing wrong with it, right? So what they did is they said, well, we're stepping on each other's feet here. So let's first copy both of them out, and then they're safe and sound in their own little integers, and then you can rearrange them at will. That's just fine. So generally, the rule of, you asked me, is that wasteful? Is that extra? Generally, if you do just a little thing like that, then that's not considered wasteful. Wasteful would be that if you could go over an array of 100 elements once, and your solution instead goes over it 100 times. Because going over an array of 100 times, that starts getting expensive. But a little thing like that, don't worry about it. Particularly on the exam, I don't want anyone to worry whether it's wasteful. Get it to work. No one will get docked to point because that might be a more efficient way of doing something. On the exam, the key is to get it to work. All right, now we can run it. I cannot compile while the machine is executing. This could cause strange problems. It's always been my thought. What do I do now?
You have to stop. You have to stop.
Yeah, I have to terminate here. This might happen to you during the exam, right? So that's why I wanted to show. So you click terminate here. Once in a while, it even happened to me that even though I clicked terminate, it didn't terminate, and this little gizmo here, then I had to right-click on it and hit on reset. So if all fails, try right-clicking and reset. That's a little bit faster than restarting BlueJ, and in an exam, of course, every minute counts. So let's run it one more time. And now it works, right? You see, these now are all properly swapped. So what do we learn from this? Lesson number 1, the debuggers. To use the debugger effectively, step through where strange things happen, but every time before you click step, think about what you think should be happening. Treat it like a little science experiment. You know how it is with a science experiment, right? You fill the little jar with roaches, you put it on the stove, and you ask yourself, what will happen when I increase the temperature? And then, does it actually happen like that? And if yes, then you know one thing. If no, you know a different thing. So, before you click on next, ask yourself, what is going to happen? try to understand what your program's supposed to do. Number two is to get some idea, take out a little sheet of paper and doodle on it and say, this didn't work, so maybe if I move it here and kind of move it out of the way, and maybe some scribbles like that will give you an idea on how to do something. All right, those are the two things that I wanted to get out of this lab.